One question that often faces the well owner is, will this well produce oil and gas? To help answer this question, one or more methods of evaluation are used, including mud logging, well logging, and drill stem testing, or DST. Mud logging involves doing tests on the drilling mud and cuttings circulated out of the hole. Well logging is the recording of information about subsurface geologic formations. Drill stem testing is a way to test a formation using the drill stem. A special tool and packer assembly installed in the drill stem records downhole pressures and temperatures and retrieves fluid samples. As the bit drills, drilling mud lifts cuttings up the hole. The drilling mud also carries traces of any hydrocarbons and other substances the hole may have penetrated. Therefore, catching and analyzing the mud and the cuttings that come to the surface can tell the well owner and geologist a great deal about what's going on downhole as the bit drills. Analyzing the drilling fluid is called mud logging. An overview of a land rig shows the mud logging unit. Offshore, a similar skid-mounted unit houses the mud logging equipment. Both contain sophisticated data acquisition systems and equipment for analyzing drilling fluid and cuttings. Here's the inside of a mud logging unit. You can see some of the equipment used to analyze or log mud. This drawing of a mud logging unit shows many items of equipment used to analyze and monitor the drilling process. Not all rigs will have such a setup, and some will have even more sophisticated setups. Rig monitors give readouts to the mud logger, a person whose specialty is observing and analyzing mud and cuttings. The rig monitors show the rate of penetration, or ROP, how fast the bit is drilling. Weight on the bit, or WOB. Total hook load. Kelly, or top drive height. Rotary speed, or RPM. Rotary torque, the twisting force on the drill string. Pit volume, the level of mud in the mud tanks. Mud weight, in and out of the hole. Mud temperature. Pump strokes. Casing and standpipe pressure. And other information. Mud loggers can combine rig information with other information from the driller, the wireline operator, and area well records to help improve the well's progress. A chromatograph displays the percentages of hydrocarbon gases in the mud returning to the surface. The chromatograph has sensors in the mud return line. These sensors detect such gases as methane, ethane, and propane that may be in the mud. The core plugging apparatus takes a small plug out of a core sample. The mud logger can analyze the plug to get an idea of what the larger core sample may contain. A fluoroscope contains an ultraviolet lamp. When the mudlogger or geologist puts cuttings or a plug under the fluoroscope, the cuttings or plug glow or fluoresce if they contain hydrocarbons. A microscope, this unit has two, helps the mudlogger or geologist identify formations. By looking at cuttings or plugs under the microscope, the loggers can note very small rock characteristics. They may also find fossils that help identify the rock. Computers help mudloggers analyze, interpret, and report information they gain from mudlogging equipment. In some logging units, powerful computers directly read drilling information, process it, and print out detailed reports on the status of the well. Mudloggers use a vacuum oven to dry out formation samples. Then, they evaluate the dried samples for further facts about the formations being drilled. Geologists use a core heat sealer to make an airtight container for cores. The heat-sealed airtight container keeps any formation fluids in a core from leaking out while it is being shipped to a core laboratory for analysis. Loggers use an analytical balance to accurately weigh rock samples. They calculate a rock's density and porosity from its accurate weight. A porosimeter measures rock porosity, the amount of pore space in a rock. The more pore space a rock has, the more space available for the rock to store oil and gas. Formation fluids such as oil, water, and gas can flow through rock formations when the rock has empty spaces, or pores. And the spaces are connected, permeable. Click on the magnifying glass to get a closer look at the pore spaces. The ratio of the volume of empty space to the volume of solid rock is called porosity. The measurement of the ease at which the fluid flows is called permeability. Loggers use a gas analyzer to examine samples of gas from the well. Gas analyzers not only indicate what kind of hydrocarbon gases the mud brings up, but also non-hydrocarbon gases, such as hydrogen sulfide and carbon dioxide. Gas that has hydrogen sulfide in it is called sour gas. Gas that contains little or no hydrogen sulfide is called sweet gas. An X-ray diffractometer penetrates a rock sample with X-rays. Different types of rock react differently to the X-rays, which allows well loggers to identify a rock structure. The centrifuge spins formation fluid samples at a high rate of speed. Loggers put the fluid samples into a test tube and then put the test tube into the centrifuge. The spinning or centrifugal motion separates the fluid into its components. The heaviest components, usually water, collect on the bottom of the tube. The lighter components, such as oil, collect in the tube above the water. A dry sample tray holds dried rock samples. Loggers put dry samples on the tray and then place the tray under the microscope, where they examine the samples. Microscopic examination of dried samples tells loggers and geologists much about a formation's characteristics. Mudloggers use hydrochloric acid, or HCl, to test for limestone. If a logger puts a drop of hydrochloric acid on a sample, and the sample bubbles up, or fizzes, then the sample contains limestone. Limestone sometimes holds hydrocarbons. This is a computer-generated mudlog. At its most basic, the log records the rate of penetration, percent hydrocarbons found in the mud at various depths, and the percentage of rock types in samples caught at the shale shaker. The log may also record other well characteristics to help the well owner drill the well efficiently and safely. What would you use to find out if cuttings contain hydrocarbons? Sorry, that's incorrect. That's right. In most wells, the owner orders a well log. A well log can reveal whether there is enough oil or gas in a formation to go to the expense of running and cementing production casing to complete the well. To log a well, the well owner usually calls a well logging company. On land rigs, the logging company sends a truck-mounted logging unit to the well. Offshore, the logging unit is usually permanently installed on the rig. In either case, the logging unit lowers a logging tool on conductive wireline into the well to the depth of investigation. The unit then reels in the tool. As the tool comes up the hole, it detects certain aspects of the formations it passes. It sends this information up the conductive wireline to the surface. On the surface, computers in the logging unit record the information. The computers then print out the information, print a log that the well owner can examine. Often, the log gives enough information for the well owner to determine whether oil or gas exists in the formation. Here's a logging truck. It contains the computers, the wireline on a reel, and the controls that make the logging operation work. Offshore, instead of a truck, the equipment is installed in a small house, a logging unit. The logging unit, whether truck-mounted or skid-mounted, houses conductive wireline on a reel, wireline controls, which allow an operator to lower, stop, and raise the wireline, and the computers that record and display the information relayed from the logging tool through the conductive wireline. The well owner can choose from many types of logging tools. Plus, the owner can run some of the tools in combination. Logging companies group logging tools into 4 broad areas: electric, nuclear, sonic, and other. Electric logging tools measure and record certain electrical properties of the formation. This is a recording, a log made by an electric logging tool as it came up out of the well past the formations. The squiggles on the log are called curves. Notice that the curves move to the left and to the right on the log. This is called deflection. A person familiar with these curves can look at the way they deflect and learn a lot about the formations. A basic premise of the simplest electric logs is that salt water conducts electricity considerably better than oil. Thus, a formation containing oil deflects the log's curve different from a formation containing salt water. A nuclear log, sometimes called a radioactive log, looks a lot like an electric log because it has curves that deflect left and right. Nuclear logs measure either natural or induced radiation in the formation. Natural radiation can indicate the type of rock and its density. Bombarding the formation with a low-level radioactive source in the logging tool can indicate whether liquids or gases are in the formation. A sonic log records the time it takes sound to travel through a formation. A sonic logging tool creates a sound that hits the formation rock near the tool. Sound moves faster through solid rock than through rock that has fluid-filled pores. The curves record the travel times and allow an expert to determine whether the rock is solid or fluid-filled. If fluid-filled, the fluid might be oil or gas. Many other logging tools are available. A common one is a caliper log. This log shows the diameter of the hole and any irregularities in it. One thing caliper logs can do is help the cementing crew determine the volume of the hole. With hole volume known, the crew knows how much cement they will need to properly cement the casing. In addition to logs, the well operator will sometimes order a drill stem test. The drill stem test, or DST, temporarily produces hydrocarbons through the rig's drill string, or stem. DSTs also measure and record formation pressure and temperature data. To determine formation permeability and the makeup of hydrocarbons, the well owner may run a drill stem test, DST tool. The crew runs this assembly on the drill string, or the drill stem as it's sometimes called. The test evaluates a selected test zone. Like well logging, DSTs help well owners decide whether to run casing and complete a well. A DST tool lets formation fluids flow to the surface, or sometimes into a sample chamber inside the downhole tool. While the well flows, the well owner can determine the producing characteristics of the well. Such information allows the owner to produce the well more efficiently when completed. Here's a drill stem test tool made up on the bottom of the drill stem. From top, it has a reverse circulation sub, shut-in valve, hydraulic bypass, recorder, hydraulic jar, safety joint, packer, perforated pipe, and an anchor shoe. The crew lowers this assembly to the depth the well owner wants to test, in this case, the bottom of the hole. You'll see what the parts do as you go along. Let's see if you can build a DST tool from the bottom up. Here are the labeled parts of the DST. Using your mouse, drag each component into place in the proper order. Well done! The crew lowers the DST tool into the hole on the drill pipe, after the well is well circulated and conditioned with drilling fluid. The hydraulic bypass is open because the DST packer has limited clearance with the upper casing and open well bore. The open bypass allows drilling fluid in the hole to flow up inside the tool as the crew lowers it. Letting drilling fluid flow up inside the tool prevents it from creating pressure surges. Pressure surges could fracture the formation to be tested. With the DST tool on the bottom, the driller slacks off the drawworks brake to put weight on the tool. Weight causes the packer to expand. The packer seals off the hole beneath it. With the hole sealed by the expanded packer, the DST operator rotates the drill string. Rotation opens ports inside the DST tool. With the ports open, formation fluids flow into the tool and to the surface. During this time, crew members closely monitor annulus pressure. They monitor annulus pressure to make sure the packer maintains a good seal between the hole section being tested and the annulus above the packer. The test crew puts water into the drill pipe above the DST tool. This is a water cushion. The water cushion supports the drill pipe against mud pressure in the annulus until the test starts. The water cushion also puts hydrostatic pressure on the formation when the DST tool ports are open. The hydrostatic pressure is, however, not enough to keep the formation from flowing into the DST tool. The water cushion is just that, a cushion. It keeps the formation fluids from surging with great force into the tool and the drill string. If allowed to surge, the force could damage the recording instruments in the tool and the formation rock. With the ports open in the DST tool, formation fluids flow. they push any drilling fluid in the hole below the packer into the tool. Then, they flow up the tool and the drill string to the surface. The test crew first lets the well flow for a short time to clear out the drill stem. They then shut in the well for a time to allow pressure to build. The well owner then allows the fluid to flow for a few hours or for several days, depending on the well. Produced fluids are caught in a holding tank or burned off as they reach the surface. During the flow period, the owner determines the well's production potential and fluid properties. After letting the well flow for the required time, the test crew closes the shut-in valve by rotating the drill string. The flow of formation fluid stops. With flow stopped, formation pressure builds up inside the tool. This pressure buildup is recorded on a pressure chart in the tool. Later, the well owner examines the chart on the surface. The record of the pressure buildup rate gives information about the permeability and size of the formation. Permeability is the quality of a formation that allows oil and gas to flow through the pore spaces of rock. Highly permeable formations allow fluids to flow easily. A formation with low permeability is called a tight formation. It is harder to produce than a formation with high permeability. To remove the DST tool from the hole, the driller first opens the reverse circulation sub. The driller usually opens the reverse circulation valve hydraulically by pumping drilling fluid down the annulus. This increased pressure in the annulus opens the sub. With the sub open, drilling fluid reverse circulates down the annulus and up the tool and drill string to the surface. Reverse circulation pumps the remaining formation fluids out of the drill stem and puts drilling fluid back in. The drilling fluid kills the well. That is, the drilling fluid once again keeps the formation pressure under control. To pull the drill string and DST tool from the hole, the driller first releases the packer by easing up on the string. If necessary, the driller uses the built-in hydraulic jar to jar on the DST tool. In most cases, jarring loosens the packer and frees the tool. If the driller cannot pull the packer free for some reason, he can separate the tool at the safety joint. Removing the tool above the safety joint gets all of the tool above the packer, including the recorder with its data.